Geometric applications of exponent rules. So at the top are some of the formulas you may need for these geometric applications. There are a few that you should memorize. The first one is the area of a rectangle, length times width, area of a triangle, 1/2 base times height, the area of a circle, pi r squared, and the volume of a rectangular prism. Those are the four that you should probably have memorized at this point in your math career. The other ones you may need to either look up on a formula chart or hopefully be given to you. So with these, we're going to use the formulas above to find an expression that represents whatever it's asking. So for example 1, it asks you, what is the volume of the rectangular prism below? So the volume of a rectangular prism is found by multiplying length, width, and height. So we're going to multiply all three of these together. So this guy right here, this is your length. This one here is your height. And this one here is your width. So in order to find volume, we're going to multiply the length, which is 3x squared, y to the 5th, times the width, which is the orange one, 1 over 3y to the 4th, and my height, which is the green one, xy to the negative 3, x to the 4th, y to the negative 3. Now again, you can either use your exponent rules or your expansions. So first thing we need to do is anything to the negative exponent must drop below your fraction. So what we have for our volume is we have v equals 3x squared y to the 5th over 1 times 1 over 3y to the 4th times x to the 4th over y to the positive 3, since y to the negative 3 moved underneath. Now, when you multiply a fraction, we multiply straight across. So the numerators all get multiplied and the denominators all get multiplied. So our volume is, well, 3 times 1. Those are not exponents, those are coefficients. So 3 times 1 is simply 3. X squared times x to the 4th. Well, if you're multiplying exponents, you're multiplying bases, you add their exponents. So this is going to be x to the 6th. 2 plus 4 makes 6. Y to the 5th, well, there's no more y's being multiplied on the top. So y to the 5th will just stay y to the 5th for now. Now for the denominator. 1 times 3, again, those are not exponents, those are coefficients. So 1 times 3 is 3. Y to the 4th times y to the 3rd is, again, adding your exponents. Multiplying bases adds your exponents. 4 plus 3 is 7. Now that we have multiplied, let's look at the division. So we have 3 divided by 3. Well, 3 divided by 3 is 1 over 1. X to the 6th has no x's being divided, so x to the 6th will stay x to the 6th. Y to the 5th divided by y to the 7th. When you are dividing, subtract their exponents and keep whatever's left over where there were more in the beginning. So 7 minus 5 makes 2, so we're going to have y squared. And there were more y's at the bottom, so this is y squared at the bottom. Now, you know you're finished simplifying when there is one of every base. So 1 over 1 is as far simplified as it can go. There's only one set of x's and one set of y's. So the volume of this rectangular prism is simply x to the 6th over y squared. Let's look at example 2. If the length of a rectangle is represented by 5a to the 5th b squared z to the 9th, that's the length, and the area is 10a to the 6th b to the 5th z to the 11th. What is the width of the rectangle? So let's think about a rectangle. We have our little rectangle here. We know that the area is 10a to the 6th, b to the 5th, z to the 11th. And we know that the length is 5a to the 5th, b squared, z to the 9th. Well, if area is length times width, and I want to solve this guy for the width, we're going to have to divide out length. So our width will be the area divided by the length. So, well, we have both of those. So width is the area, 10a to the 6th, b to the 5th, z to the 11th, over the side length, 5a to the 5th, b squared, z to the 9th. Now that we have set up the problem, solve it using your either the exponent rules or expansion. So forget these exist. 10 divided by 5 is 2. 10 divided by 5 is 2 over 1. Now we have a to the 6th divided by a to the 5th. So dividing bases subtracts the exponents. So 6 minus 5 makes 1, And there are more a's at the top, so we're going to put a to the first at the top. Then we have b to the fifth divided by b squared. Again, dividing means subtract the exponent, so 5 minus 2 is 3, and there are more b's up top, so b to the third. Finally, we have z to the 11th over z to the 9th. Again, division, subtract your exponents. 11 minus 9 is 3. 11 minus 9 is 2. And then keep them where there's more, which was at the top, so z squared. So our final answer is 2a b to the third z squared. There's the missing side length. Let's look at 3 and 4. So for number 3, find the area of a square that has a side length of 5a to the third b to the negative 3 inches. Well, if you want the area of a square is similar to area of a rectangle. It's still length times width. But the thing about a square is that all the sides are the same. So if it gives you one side length, you know them all. Well, this is the length and this is the width. Length and width. So we're really just multiplying something to itself. So my area is going to be 5a to the third b to the negative 3, there's my length, times the width, 5a to the third b to the negative 3. So I want you to pause the video and I want you to try to find the simplified area on your own. Remember to move any negative exponents before you start either expanding or using your rules. Pause the video, try it out. And here's your result for example 3. Now let's look at 4. What is the area of a circle that has a radius of 4d to the third j? So area of a circle, formula is a equals pi r squared, where r is your radius. Okay, well, it tells me the radius. It says the radius is 4d to the third j. So we're just going to substitute that in. So we have area equals pi times the radius, 4d to the third j, squared. So this is the one rule I don't suggest using, because sometimes this is the one that's difficult. Well, if I have a squared on the outside, that means there's two of these multiplied together. So a is equal to pi times 4d to the third j times 4d to the third j. So now that I have this expanded, let's use our rule. Pi is just going to stay pi. We're not going to change pi to 3.14. So far we just have pi sitting here multiplied to a bunch of stuff. So 4 times 4 is 16. D to the third times d to the third. When you are multiplying, add your exponent. So 3 plus 3 makes 6. And then j times j will be j squared, because there's a little 1 exponent here that nobody writes. Now, to kind of clean this up just a little bit, we actually don't leave pi in the front. We kind of treat pi like a variable. And so the correct way to write this is 16 pi, because those are still multiplied together, d to the sixth j squared. So we don't leave pi in the front. Kind of like we don't write x times 2, we change that to 2x. For a similar reason, that's why we rewrite pi after the coefficient. So what I'd like you to do is I'd like you to pause the video and try example 5. There are a few test-taking strategies at the top to help you out. So pause the video, try example number 5. And here's your solution for number 5. Remember to divide coefficients and subtract exponents of bases that are divided. So number 6, which expression best describes the volume of a rectangular prism that has a height of 5x to the fourth units and a square base with side lengths of 3x to the fourth? So this gives you lots of information. I have a height of 5x to the fourth from a rectangular prism and a square base with side lengths of 3x to the fourth. So if it helps, draw out a picture. Here's our picture. We've got a square base. Here's the best square I could draw. So these lengths are all the same. So square base. And we have a height of 5x to the fourth. So we have 5x to the fourth. The square base is 3x to the fourth units. So 3x to the fourth and 3x to the fourth. So if you want to find volume, you need to multiply length, width, and height together. The idea of the square base gives you two of those lengths and widths. Okay, the height, the length, and the width. Pause the video, try out example number 6. And you should have had choice C. 3 times 3 times 5 is the 45 piece, and x to the 12th is the variable piece. Here's a test-taking strategy. Pretend like you didn't have the variables. What would you do if it was 3, 3, and 5? Well, you'd multiply them all together. So that at least gets you the 45. And in this case, it actually solved it out for you. Sometimes if you have two 45s as choices, at least it'll knock you down to a 50-50 chance. Here's example 7. The surface area of a sphere can be found by using the formula S equals 4 pi r squared, which expression represents the surface area of a sphere with a radius of 5x to the fourth y z to the third unit. So that's my r. So if I plug in, surface area equals 4 pi times my radius, which is 5x to the fourth y z to the third squared. Now again, this is the one I would suggest expansion. So surface area equals 4 pi times 5x to the fourth y z to the third times 5x to the fourth y z to the third. But notice, it's only there two of these. This 4 pi is not included on that square, so this 4 pi just drops down. This is the only thing that's included in the square, so that's the only thing we double. Now that this is all expanded out, start simplifying using your rules. 4 still counts as a coefficient. So 4 times 5 times 5. 4 times 5 times 5, drop pi. Then x to the fourth, y times y, z to the third times z to the third. So pause the video, finish simplifying this one out. And you should have had A as your solution.